Hello, good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Virtual, and today we're going to take a look at a homework assignment that a student brought in that has to do with linear relationships, linear representations, linear functions. Um, so the student was given a numerical piece of information called just a table, kind of like a typical XY table. So here's my X information, here's my Y information. So that when we go ahead and we graph it, I kind of live in quadrant one for real life situations. So I have an X and a Y, a piece of information. These are going to be the years, and this is going to be my population for the city, whichever city this may be. We are going to talk about how this is going to look like in an algebraic setting and what this is going to look like in a verbal setting. So in an algebraic setting, we know that since this is a linear relationship, we know that our linear function is going to look in the form of y equals mx plus b. Now, this is my slope-intercept form. We can totally find all of the information that we need to from here, but I think it might be a little bit easier to focus first on the slope. So we're going to look for the slope first, and that's y2 minus y1 over x2 minus x1. And then we're going to plop it into not this slope-intercept form, we're going to plop it into point slope form. And point slope form is y minus y1 equals the slope times x minus x1. So this is going to be my first point, and this is going to be my second point. So I'm going to go ahead and I'm going to say 27,800 minus 23,400 over 2012 minus 2008. So my denominator will be 4. That's a little easier. And then this will be 400 and 4,400. So when we simplify this, we're going to have 1,100 over 1. So that's going to be my slope. So I'm going to put my slope, once I find the slope, this portion of the problem is done. I can then go ahead and put my slope in here. So my slope is 1,100, and I know that I don't need to put it over 1 just because it's kind of like a more basic piece of information. And I'm just going to take this first point and use that. So I'm going to have y minus 23,400 and then x minus 2008. And all I'm going to do in here is solve for y and get y on its own. So I don't know about you, but I'm going to need to use a calculator for 1,100 times 2008. Whoa. 1,100 times 2008 is quite a large number. So I'm going to have, just distribute this 1,100. Holy guacamole. Whoops. I guess it shouldn't be too much of a surprise, but here we are. And then here we are as well. We are going to go ahead and add this 2,300 to that. And so we're going to end up with y equals 1,100x minus 2, 2, oh, whoops, not oh, 2, 2, 3, 2, 200. And this should be where my entire equation looks like. However, this is at a negative, which makes me think that this negative piece doesn't quite make sense. And I wonder if if the teacher's intention was to say, hey, this is 8 years after, this is 12 years after. So instead of saying, oh, we're going to look at 2014 minus 2008, I guess we're looking at year zero, 2000 years ago. And 2012 years ago, the city's population would be pretty much at negative, and then we would go up 1,100 every single year. I wonder though when, yeah, I guess this is when we would have this at negative. This point here would be negative 2 million. And then it would go up in this 1,100 over 1 to the point where it would hit at year, this point here would be 2008, right? And that would be 23,400. The verbal piece in here, I would probably say, would be somewhere along the lines of in the year 2008, there are 23,400 people living in the city. The population grows at a rate of 1,100 people per year. Something along those lines would be kind of like where we are with this information. I hope that this was helpful and not too speedy, and let me know. I will see you in another video. Bye.